Hello all. Uh, let's see a question from GATE 2019 Mechanical Engineering Paper 1. The question number 25. So you have been given a stress strain curve here, and you are so the condition is you load the material under uniaxial tension from point O, and it will reach its initial yield point at point P, and then the strain hardening happens till point Q. Now it is unloaded again back to point R where the stress is 0. Now the question is, at this state, if you start loading it, reload it from point R, then what is the value of stress at which the material yields again? The concept here is about strain hardening, as you can see. So before going into the problem, if you want to actually learn more detail about it, you can check out this NPTEL lecture, Introduction to Material Science, by Professor Rajesh Prasad, IIT Delhi. So let's go into the problem. So let's analyze this system. What is going to happen at first? So typically, when you do a uniaxial uh, tension, you are going to take a specimen like this, which is like a dog bone type of specimen. Okay. Initially, you will have some dimension, right? So when you so since it is tension, you are going to pull this. So when you move from this point to this point, this particular case it elongates, right? Yes. So you will get something like this, and from this point again it deforms more. So let's say finally you are getting right. So let's mark this. This is point O, point P, point Q. So now you can see how much this thing has deformed. So your latest deformation is roughly this much, considering this as the length. Okay, so now what is happening is it is being unloaded. So when you unload it along this path, it reaches this point and this much deformation is remaining. So this much is your irreversible plastic deformation, right? So that means upon loading and reaching this point, your specimen would have been still deformed. It would have been still deformed, and it would have been elongated more than what was here. So when you start again from loading from this point, it won't deform so much. It won't deform much if you load again. So it will go again in this path. Okay, so let's draw that state from R. So what will happen from that point R? So let's say this was my initial P point. Now I'm starting again loading from R. So what will happen is it will reach again with the minimal, very minimal uh, change in the strain. It will reach that point. Now when will it start yielding again? Will it start at this point, or will it start at this point? That is the main idea here. So what will happen is, this, since it is already elongated, during this particular phase there won't be much yielding generated. During when you go from this point, that is basically R to Q, there won't be much changes. it will start deforming only after this point where it was unloaded. So because of its deformation, that is the main reason. Because you can see that it was here like this, but you have already reached a stage which is already elongated so much. So when you load it until you reach this point and elongate it further, it won't deform. So that is this point Q. So it will reach this point Q, it won't deform till then, and then the deformation starts. So that means my yielding, that is the yielding that they are asking, is going to start after point Q. So they have asked where this yielding will start. So the answer will be 210 MPa. This is where the yielding will start. So I hope you understood this problem. You can check out more why is this strain hardening behaving like this. Um, so you can check out the NPTEL lecture for understanding this process further, why such a behavior is observed. So I hope you understood the problem. So thank you. Thank you all.